Welcome students, this is your first video for the second semester. It's on changing slope and y-intercept in real world problems. We did this back in the first semester, but we did it just on a graph and in tables. We didn't do it associated with real world problems, so we're going to look at it in that context today. Okay. It says, what are the jobs of the slope and the y-intercept? The slope changes the steepness of a graph, so it makes it flatter and it makes it steeper. The y-intercept shifts, slides, or translates the graph up or down. So it just moves it up and down on the graph. Words associated with each one, words associated with the slope, the letter M is the word rate, or the word rate of change, per, for, or for each, rise, overrun, are all words associated with slope. With y-intercept, they all go around the word start, begin, initial, or flat, P. Okay? You may even see the word deposit sometimes if it's like a deposit down on something. Alright, this first problem says Sam works as a bicycle courier, so that means he delivers stuff on a bicycle. It says she earns $10 plus 75 cents for each ounce that she weighs. So this starts at $10 because that's her base salary, and then it goes up at 0.75, and 0.75 as a fraction is up 3 over 4. Okay. What does it mean if the slope of the graph were doubled? So that means that this would be twice as steep, or she makes 2 times 75 cents, or $1.50 per ounce. Okay. What does it mean if the slope of the function were changed to 0? It means that the graph would start at 0, 0, and and she only earns per ounce. So that way she doesn't make that flat $10 anymore. She starts out at $0 and only earns per ounce. What would it be if the slope of the negative line would go downhill, which would be weird in the real world situation because it would mean that Sam is paying to work, like she would be giving them money to work, which doesn't make a lot of sense in the real world. Example 2. Melinda is driving home at a speed of 80 kilometers per hour. Her distance from home is shown below. So she started out 400 meters from home. She reached home at about 5 hours. What would it mean if the y-intercept of the graph increased by 40? So line shifts up, and in the real world that means that Melinda has to drive 40 km more, so 40 kilometers more. If the y-intercept is halved, how would the total amount of time it takes Melinda? So instead of going 400, she goes 200, but we don't change our slope, so the line is going to be parallel, and so you can see that it takes her less time to get home, and that makes sense. If you had 400 kilometers to go and then you only have 200 kilometers to go, it's going to take you less time to get home. Alright, currently the cost to bowl a game, so this is like the price for the lane, is $8.40, and the cost to rent shoes is $1.15 per pair. So this per is our slope, $1.15 per pair. Whoops, put that in the wrong place. $1.15 per pair. The y-intercept is that flat fee. It costs us $8.40 to get started. So our equation is that y equals $1.15x plus $8.40. That means we get the lane for $8.40, plus it costs $1.15 for everybody that we have bowl in there for their shoes. So a different center, Big Bob's Bowling Center, has decided to attract more customers by lowering its price. The new prices can be represented by the equation y equals 0.50x plus $8.40, where y is the total cost in x. So our slope in this one is 0.5, which really means 50 cents for shoes, $8.40 for the lane. What is the difference between the original cost to bowl at Big Bob's and the new cost? All we would need to do is subtract the $1.15 and the 50 cents, and that would tell us how much cheaper it's going to be per person to bowl. So $1.15 minus 50 cents is 65 cents. So it's going to be 65 cents cheaper now per person. How does this price change affect the cost for 4 friends to bowl at Big Bob's? So 4 friends at the other place would be $1.15 times 4 plus $8.40. So that would be $1.15 times 4 plus $8.40. $13 to bowl. But at Big Bob's it's only 50 cents times 4 plus $8.40. It's $10.40, which is a difference of $2.60. So it's now $2.60 cheaper to bowl at Big Bob's. All right. To rent a car at Rex's rental car costs $75 plus 20 cents per mile. So there's your per, that's your slope, 20 cents, and a $75 flat fee. So it's y equals 0.20x plus 75. Rex decides he wants to change his rate. The new rental rate can be described by the equation y equals 0.20x plus 100, where y is the cost and x is the number of miles drawn. So the slope has stayed the same. Y-intercept changes to 100. How did the cost for renting a car at Rex's change? The initial fee is $25 more. And that's it.